Hello students, our next topic electrostatics of conductor and dielectric. Here let me see the book back questions. Our first question, that is 2 mark question, what is polarization? Polarization, okay, that means in the presence of external electric field, the dipole moment is induced in the dielectric medium, that is known as polarization. Okay, it is simply defined as total dipole moment per unit volume of the dielectric is known as polarization. Okay, it is denoted by the symbol P vector is equal to chi e, E external vector. Here chi e is the electric susceptibility of the material. Okay, polarization is the alignment of dipole moment, okay, in the dielectric medium, that is known as polarization by applying external electric field. Okay, the next question, that is what is dielectric strength? When the external electric field is applied to the dielectric is very large, it tears the atom apart so that bound charges become free charges. Then the dielectric start to conduct electricity. This is known as dielectric breakdown. Okay, first of all, we are applying external electric field to the dielectric. Okay, by increasing the electric field strength, then it tears the atom of the dielectric and the bound charges became free charges. Then after, the dielectric start to conduct electricity. This is known as dielectric breakdown. Okay, we need to know what is dielectric strength. Okay, the maximum electric field the dielectric can withstand before it break down is known as dielectric strength. Okay, for example, the dielectric strength of air, that is E is equal to 3 into 10 power of 6 volt per meter. By applying this electric field, then only the air will conduct electricity. Okay, there is a spark. You will see in the 5th lesson, Head's experiment. Okay, there will be a spark between the 2 electrodes. Okay, we are applying this much of electric field between the electrodes. Okay, at that time the air will conduct electricity. This is a dielectric breakdown of air. Okay, the maximum electric field the dielectric can withstand before it break down, that is known as dielectric strength. Okay, beyond this the air will conduct electricity. Then short answer question, that is 3 mark. Discuss the various properties of conductor in electrostatic equilibrium. Okay, let me see the properties of conductor at electrostatic equilibrium. Okay, before going to that, we need to know what is electrostatic equilibrium. Okay, an electrical conductor has, we know, large number of mobile charges. Okay, that means they are free to move in the material. In a metallic conductor, these mobile charges are free electrons which are not bound to any atom. Okay, this know you very well. Then when there is a no external electric field, the free electrons are continuously move in a random manner. Okay, as a result, there is no net motion of the charge in a definite direction, so there will be any current. Okay, this is known as, okay, electrostatic equilibrium. See, first of all, the electrical conductor has large number of mobile charges. Okay, in metallic conductor, these mobile charges are known as free electrons. Okay, without applying the external electric field, the free electrons are in random motion in all direction. Okay, so there is no net motion of the electron or no net transfer of electrons from one point to another point in a specified direction. Okay, so which implies that the conductor is in electrostatic equilibrium, that is known as electrostatic equilibrium. Thus at this electrostatic equilibrium there is no current, that means there is no net current in the conductor. Okay, then let me see the properties of conductor at electrostatic equilibrium. Okay, first point, electric field is zero everywhere inside the conductor. This is true regardless whether the conductor is solid or hollow. Okay, electric field inside the conductor will be zero. Okay, the conductor may be solid or hollow. Then second point, there is no net charge inside the conductor. The charge must reside only on the surface of the conductor. Okay, there is no net charge inside the conductor, the charge must reside only on the surface of the conductor. Okay, then the third point, the electric field outside the conductor is perpendicular to the surface of the conductor. Okay, it has a value that is sigma by epsilon naught. Here sigma is known as surface charge density. Then last point, electrostatic potential has the same value on the surface and inside the conductor. Okay, four important point. Okay, first point, the electric field inside the conductor will be 0. Second point, there is no net transfer of charge, there is no net charge inside the conductor. Okay, all the charges must reside on the surface of the conductor alone. Okay, then third point, electric field outside the conductor, that is always perpendicular to the surface of the conductor. Okay, having the magnitude sigma by epsilon naught. And the last point, electrostatic potential has the same value on the surface and inside the conductor. Okay, the next question, write a short note on electrostatic shielding. Okay, electrostatic shielding is a process of isolating certain region of space from the external electric field. Okay, we are isolating certain region of space from the external electric field. That process is known as electrostatic shielding. Okay, it is based on the fact the electric field inside the conductor are hollow or solid, okay, is 0. Anything placed inside the cavity of the conductor will be completely shielded from external electric field. Okay, here we are considering a conductor. Okay, inside the conductor there is a cavity. Inside the cavity the electric field will be 0. Whatever the electric field outside the conductor or whatever the electrical disturbance outside the conductor, okay, the electric field inside the cavity must be 0. This process is known as electrostatic shielding. Okay, using this technique alone, during thundering time, okay, it is safer to sit inside the car. Okay, this is a process we are using in the cars. The next one, explain the process of electrostatic induction. For this question we need to understand 4 diagram. Okay, let me see. So next question, process of electrostatic induction. First of all, we need to know what is electrostatic induction. Charging without actual contact is known as electrostatic induction. Okay, first of all, I consider a uncharged conducting sphere. Okay, at rest, that is placed on a insulating stand. That is placed on a insulating stand. Okay, after that I am moving a charged, negatively charged rod. Moving the negatively charged rod nearby the uncharged conducting sphere. Okay, at that time the negative charges in the conducting sphere that are farther apart, coming and settled in the location. Okay, at the same time positive charges are attracted near the region of this charged rod. Okay, at the next instant, I am connecting the charged wire, wire. Okay, simply wire. This is not replaced. Okay, I am connecting a simple wire to the ground. Okay, at the next instant all the negative charges are grounded. Okay, all the negative charges are grounded. Then this became like this. Then the ground is removed. Okay, at that instant positive charges alone attracted towards this charged conductor. Okay, then next instant I removed the charged conductor, negatively charged rod. Okay, at that time all the positive charges are distributed on the surface of the sphere. This is known as electrostatic induction. Okay, process of inducing the charge without contact. Okay, first of all let me see, Here first of all I consider a uncharged conducting sphere. Okay, for that case it will be neutral. Then I am placing that uncharged conducting sphere on the insulating sphere. Okay, sorry, insulating stand. Then I move the negatively charged rod nearby this uncharged conducting sphere. At that instant, negative charges in the sphere are repelled and located in this place, and the positive charges are attracted nearby the region of the rod. Okay, after that, connecting a wire to the sphere and it is grounded. At that instant, all the negative charges are grounded. Then the grounding wire is removed. Then it became like this. Okay, all the positive charges are attracted towards that negatively charged rod. Okay, then after removing the rod, then all the positive charges are distributed on the surface of the sphere. This is known as electrostatic induction. Okay, next question. Explain dielectrics in detail and how an electric field is induced inside the dielectric. Okay, first of all we need to know what is dielectric. Dielectric, it is nothing but a non-conducting material having no and has no free electron. Okay, this is known as dielectric. The electron in the dielectrics are bound within the atom. Okay, for example ebonite, glass, mica are the example for dielectric. Okay, if suppose when an external electric field is applied, it realign the charges so that an internal electric field will be produced. Okay, the magnitude of that internal electric field is smaller than that of applied electric field. Therefore, the net charge inside the dielectric is not zero. Okay, but it is parallel to the external electric field with the magnitude less than that of external electric field. Okay, for example, here we are giving a situation. Here there is two plates, positive and negative plates on the both side. In between the two plates there will be a dielectric medium. Okay, dielectric slab. Okay, the uniform electric field between the plate act as a external electric field. Okay, then which polarize the dielectric placed between the plate. The positive charges are induced on the one side and the negative charges are on one side. Okay, then this will induce internal electric field. Okay, but inside the dielectric the net charge is zero. Okay, even in a small volume, we can consider for a small volume the electric field will be zero. Okay, so the net charge will be zero. So the dielectric in the external field is equivalent to two oppositely charged sheet with the surface. Okay, having the charge density sigma b and minus sigma b. Okay, let me see the important points needed to answer this question. The question is explain dielectric. We need to explain what is dielectric. Okay, dielectric is a non-conducting material. Non-conducting material. Okay, then the second point, it has no free electron. No free electron. For example, glass and ebonite. Okay, then we need to answer the one more question, that is how an electric field is induced inside the dielectric. Okay, for that first of all I consider a two capacitor plate. Okay, this is positive plate, this is negative plate. After that there will be a electric field in this direction. Okay, it is a E external. Okay, then we are placing a dielectric slab. Okay, after placing this, the dipoles are aligned in the direction of the applied electric field. Okay, so it will align. Align like this. Okay, dipole having two charges, then positive charges are here, negative charge here, negative positive, negative positive, here also negative positive, negative positive, negative positive, negative positive, negative positive, negative positive. Okay, after this alignment it will produce an internal electric field. Okay, that is due to this charge, this behave as a plate. Okay, like this plate, it will produce an electric field in this direction. Okay, this is Ex internal. This E internal must be having the magnitude that is less than the E external. Okay, due to this, the electric field or the net electric field is in the direction of external electric field, that is parallel to the external electric field. Okay, inside this dielectric, that means dielectric slab, the net charge for a given volume will be 0. Okay, then this will act as a one plate, this will act as a one plate. Okay, this have the charge density that is minus sigma b, this have the charge density that is plus sigma b. Okay, these are known as bound charges. Okay, these are the important things you have to remember to answer this question. Okay, thank you.